Aloha and welcome. We're going to be going over Project 5.2 Gradient Color Light. This is really going to be a short video because this project is pretty bad. All it does is it reuses the hardware that we set up in the last project, and it does a bunch of nice, cutesy, complicated math that it doesn't really explain. So I think this is pretty worthless for us to use here. But I'm going to go through it real quick just to kind of explain it. It's talking about how in the last project we had some random colors and it was kind of stiff, but we didn't, they wanted to do something that's a little bit smoother than that. So what they want to do is come up with some color changes. So the idea is they want to go along this color swath here and kind of gradually go from one color to the next. So what they've done is they've come up with this code that's going to essentially, let me go through it. I'll give you the overall, but I'm not going to get into the specifics of the math because it's complicated, cutesy, and I don't think it's going to do us any good here anyway. But they set up the 3 pins as before. They set up the PWM functionality on them, set the frequencies to 1,000, all 3 of them. And then it has the set color here, which is doing, it's setting the duty cycle to 65,535, which is essentially 10 to the 16. The reason it's this number is the PWM sensitivity is 10 to the 16 on the Pico. This is as high as it can go in PWM. So it has to, it keeps it, up to that. So it's doing, when it's setting the color, it's breaking into the red, green, and blue bands here, or color channels. And it's doing 65,535, which is the maximum it can do for PWM. And it's subtracting out the red channel, and it's doing a bitwise shift of 4, 1, and 0 to get the different channels of the RGB essentially. So it's taking the RGB number, it's just a single number, and it's doing a bitwise shift of 4 to the right, and then 1 to the right, and then 0 to the right to get out the RGB channels here. So I'm not going to get into the math of why that works and everything else. It's really not really something that we need to worry about. And then the wheel function itself, well, let's go. So what we're doing is we're doing a continuous loop. We're going from 0 to 65535, which is the range of the PWM function. And then it's going to set the wheel according to that number, 0, 1, 2, 3, blah, blah, blah. It goes up here to wheel position and says wheel position is equal to the position that we just sent in, like, let's say 1. Then we're going to modulo it with 65,535, which should give us back just the number there, the remainder part, which will be itself. And then we're going to check and see if it's 21845, between 21845 and 43690. And then it's going to do an OR for the rest of it. What I want you to realize is they're breaking this up into 3 different parts. So they're taking that number and they're saying that, hey, and this is what I want you to realize. If you look at this, you're going to come up with certain dividing areas in the numbers here. And if you divide them evenly, if you divide 65,535 by, let me pull up a calculator here. If you bring up a calculator and you take 65,535 and you divide it by 3, you're going to get 21,845. So what it's doing is it's saying, well, if the number is less than 21845, in other words, if it's the first channel, we're going to do this nice funky math on it. We're going to take 65,535. We're going to minus the wheel position times 3. We're going to do a rightwise or left bit shift of 4, and then we're going to OR that with, or we're going to do the bitwise OR with the same thing multiplied by 3, left shifted by 1. And it's not getting, what we're doing is we're modifying our red, blue, and red, green, and blue channels here. And it's not really explaining why exactly you're going to do this to increment, each channel incrementally, but don't worry about that. I just think this is a wasted opportunity. They did a lot of fancy math here, and they didn't get into the explanation of how it works that way or anything. So don't worry about it. This isn't going to come up, I don't suspect, in later things. But what you need to know essentially is that they're breaking it up into the 3 channels here, and they're testing it to see which channel it's in, doing the increment and everything. And then they're going to, they're going to take that result that it gets from it, and they're going to push that into the set color. The set color is going to set the red, green, blue channels. So it's just going to do that, and it's going to increment one after the other. So this is essentially it. I'll go ahead and I'll show you the code. The code is the same as it was. The only thing I do in here is I changed this sleep was 10 milliseconds. And if you like watching paint dry, I suggest you keep it at 10. I mean, it's wonderful, but let me do a run and I'll show you what that looks like. So let me switch back to, so this is the, you can see how slowly that's changing. I really do apologize for it being that bright. You can't really tell, gentle gradations, but you can see that's 10 milliseconds. It's just slowly going through it. But I like to change that 10 milliseconds to 1 millisecond, just because I don't have the patience to, to watch. So if we stop it and run it again, you'll see it moves a lot quicker through the color band. So yeah, this is all it's doing. So if you have your hardware schematics from last time working, then it should work just fine. Just load up the new code and run that, and you should be fine. And go into that time.sleep_ms, change that 10 to a 1, just to get a little bit faster for you and keep you sane. So anyways, that's the last for this week, the 5.2 gradient color light. If you have any questions, as always, feel free to send me an email and I'd be happy to help. I'll see you in the next video.